Hi, I'm Josh Lee, and today I'm going to be presenting DevOps as a foreign language, or why there are no junior SREs. I'm really excited for this presentation that draws on some of my learnings from linguistics. So let's get started. So this is a quote from Kelsey Hightower from 2017, and at the time Kubernetes was about 3 years old, so I am actually curious if Kelsey would update this quote. But I think it's very salient to the discussion that we're going to be having today, which is about really just the steepness of the learning curve that we encounter when we start to deal with the technologies that we now use for running and operating software. It's gotten a little bit out of hand. I think everyone realizes this, and we need to do something about it. So I have a few ideas here. Maybe they will be helpful. Maybe they won't. But these ideas in particular come from the field of academia because the process of learning is not new. Humans have been doing it for as long as we've been humans. And even if Kubernetes is only 10 years old, we have a long history of learning how to do things better as humans that we can draw on when we're trying to learn how to do Kubernetes or whatever DevOps looks like to us. So just to start out, let's define the field of second language acquisition. Now, this is a really interesting field that pulls from the lessons in linguistics, psychology and neurology, sociology, and brings them all together, right, to kind of try and understand the process by which adults learn second languages. Now, in the academic definition, a second language is not necessarily the second language you learn, it's just any language that you learn after puberty. So it's not one of your native languages, right? So whenever I say second language today, that's what I mean. It's just not a native language. Now, since we're talking about linguistics, I need to set a few ground rules. These 2 points are taken as essentially axiomatic in most corners of the field of linguistics. So all children have the capacity for natural language and will learn one simply from exposure, and all natural languages are equally expressive. So if you take the ideas from this talk and decide to go have conversations about this with your friends, then I hope you'll just keep these 2 points in mind. And especially the second point, all natural languages are equally expressive. So while it's perfectly okay to make fun of constructed languages like PHP, we should definitely avoid making fun of natural human languages, because that's just a stand-in for making fun of the people who speak that language. And so, right, here's the disclaimer, written languages and constructed languages are not natural languages. And that's also relevant because some of the lessons that I'm drawing from here are actually built into our brains, and we can point to some of the physics that actually makes this work when we're talking about natural languages. Now, I'm using this metaphor and trying to apply these lessons to constructed languages, but the process by which we learn constructed languages is not studied as thoroughly, and we don't know for a fact that this is actually hardwired into our brain this way. So now I'd like to introduce a figure that we'll be talking about a lot today, and that's Stephen Krashen. So he's still around. This is a fairly recent photo, but in 1982, he put out the Principles and Practice in Second Language Acquisition. And this was a seminal paper for the field of second language acquisition that provided 5 really important hypotheses that are part of collectively referred to as the input hypothesis, although that is also one of the 5 sub-hypotheses. So here are the 5 hypotheses. Don't worry if these don't make sense to you yet. We're going to go through each one of these in detail, and we're going to talk about them, and then we're going to talk about how they apply to our process of learning how to do DevOps better, right? So the first theory is the comprehensible input hypothesis. Now, essentially what this hypothesis says is that humans learn best when we get new inputs to learn from, and those inputs are of size I plus 1, where I represents things that we already know really well and understand. And that plus 1 is the new thing that from the context of all of the I, we will be able to figure out. And a corollary to this hypothesis is that the larger I gets, right, the more that you know, the smaller the relative size is of I to 1, and the easier it is to integrate that new knowledge. But when we're starting out, our I is essentially 0, and that can be really challenging. We kind of have a natural understanding of this when we're trying to learn other things, right? When a kid tries to ride a bike, we maybe start them off on a tricycle, then we give them training wheels, and they're slowly learning the concepts and layering them on top of each other, right? You learn how pedals work, you learn how momentum works, and then eventually you get to the place where you're able to combine momentum and balance and successfully ride a bike. But if we think about how people learn DevOps today, I think that it looks a little bit more like this. And this is what this is basically a junior SRE with a shiny new MacBook right here. It might work. They might eventually get to where they're going, but there's certainly going to be a lot of unnecessary confusion along the way. So our next hypothesis is the acquisition and learning hypothesis. Now, essentially what this hypothesis says is that the process of learning, that is reading theoretical knowledge, listening to talks like this, and other abstract methods of learning, right? That is necessary, but it is also necessary to have acquisition style learning where we're putting into practice the things that we theorized about and solving real problems. And only by combining both of these methods can we actually integrate new knowledge into our brains. Now, a few weeks ago, I was at another conference, and there was a great presentation explaining the EDIP process of learning. Now, this is common in, I think, gym courses and in the military, if you can believe it, but I think it's very applicable here. So EDIP is explain, demonstrate, imitate, practice. And this is a process of learning new skills. It's very popular in physical things where the imitation step, you can see how valuable that would be in the learning process, right? But I think that a lot of us, myself included, probably came into software development or operations or wherever we are right in the field, we probably came into it starting at step 3, starting at the imitation, right? We saw something, we're like, hey, I can maybe fix that, I can make that work, or I can make something work that looks like that, and then someone gave us a job. Silly them, right? And maybe, if we're lucky, we eventually went back and filled in some of the theoretical knowledge that we didn't have. Or maybe you have a computer science degree, and so you actually did start with a lot of theoretical knowledge and eventually got to the practitioner part later in your career. Whichever way that you did it, this process never ends. So when I saw EDIP, my immediate thought was, oh, we have acquisition on the left, and we have learning with these 2 steps on the right. And if we can combine these into a loop, and that is the important part, the loop, we're constantly going back. We're layering in new knowledge and reintegrating that knowledge into our mental models of how the world works and how our tools work. So we need to combine acquisition and learning constantly as we achieve new goals and reach deeper understanding. The third hypothesis that we're going to be talking about today is the natural order hypothesis. So this hypothesis essentially says that there is a natural progression for learning complex systems like languages. Now, this is one that gets really actually particular into the neurology of the human brain, and there's a thing referred to as the language acquisition device that is theorized in linguistics and neurology. And the theory is essentially that all children have this language acquisition device somewhere in their brain, and that they will essentially learn a language in the order that the language acquisition device prescribes. So I don't want to stretch this too far for the purposes of our metaphor, but just know that this is really strict in actual linguistics. And for us, we're just kind of talking about things, right? These are just ideas. So when I think about the natural order hypothesis and how it relates to DevOps, I kind of think about tech trees. So this is from a video game called Crying Suns, and it's not a tech tree so much as it's a tech web, and it might actually make you cry. But it also looks really familiar, unfortunately familiar to this. And while every single tool on this screenshot is an awesome tool, this landscape, and this is the simplified version, right? Folks at the CNCF have put a lot of work into making this simpler and easier to understand. That still does not provide a very bright red arrow that says you are here or start here, right? So someone who's not familiar with any of these things, it's absolutely overwhelming. What I think we need is something that looks more like this. It's not that everybody is going to take the exact same path through the learning journey, but I think we really need to carefully consider the steps in which we learn things and how we build on top of them in order to reach productivity with our tools. This is the Civ5 tech tree. I think it's very well designed, and I think that we could think about this when maybe we're building platforms or developer tools. Okay, so the next hypothesis is the monitor hypothesis. And essentially what this hypothesis says is that all of us naturally, innately have a built-in monitor. We're always evaluating everything that we say in the context of a spoken language to see if it feels right or not. And if it doesn't feel right, there's kind of a little thing that just goes like, eh, and we might not know the right thing to say, so we might just utter the wrong thing knowing that it's wrong. And the people that we're speaking to generally are going to meet us where we're at, right? They're not going to make us explain ourselves. Most of the times they won't even correct us, which can be challenging when you're trying to learn a foreign language. But that's very different from the tools that we use when we're building software, which if you have one character off or one flag missing, you can get a completely different output from what you were expecting. You can get a completely different result from what you're expecting. Now, here's a really, really basic example of that, right? I know that the command to check the version of Docker is --version or -v, right? Either one of those works. I just happen to know that. That's a bunch of implicit knowledge, and there's a lot more implicit knowledge like that that I have inside my head that someone who has never used Docker and never built any software before, they're not going to have that. And they might run Docker version. Now, I ran Docker version. I was just kind of curious to see what would happen, and my prompt just hung like this. I don't know what Docker was trying to do in the background there. I'm actually using Podman, so yeah, I don't know what Podman was trying to do there, but it just hung. And if I didn't know Control C, which if I'm just learning Docker for the first time, odds are pretty high that I might not know Control C, I'm just stuck. I just have to close my terminal, and that's a really frustrating moment. And that frustration can kill my motivation to learn. And that brings us to the fifth and most important theory that we're talking about today, and that is the effective filter hypothesis. So what the effective filter hypothesis says is that we learn best when we are both motivated and in the right mood. This is really important, and it relates back to everything else that we've just been talking about. We are humans. We need to have the motivation to know why we're doing something, or our brain will simply refuse to integrate the new knowledge. Got it? Okay, so you may be thinking, Josh, this is all great. You've just presented a bunch of problems. Do you have any solutions? What can we actually do about this? Don't worry, I definitely do. These were somewhat crowdsourced, and I thank everybody who participated in the various discussions that I've held this year to gather these solutions to this thorny problem. So the most important solution, and I kind of alluded to it already, we have to know our why. We have to know why we're doing this, both in a macro sense and in a median sense, right? Why do I want to be an SRE or a software engineer? Why do I want to be in technology? And also, why am I trying to get this Node.js application working right now, right? Like, what is that one next step going to actually do for me in my life? We need to acknowledge the humanity of everyone around us, right? Both the people teaching us and the people we're teaching. Humans are humans. They're not going to behave the same way every day, and they're not going to be at their best every day. We are building socio-technical systems, and we have to keep that in mind. And with that in mind, psychological safety is the most important gift that we can give one another. So we need to always be working in and providing a safe environment, and that enables both productivity and learning. It's really a no-brainer. But unfortunately, our natural tendencies can lead us away from this. And so we need to keep reminding ourselves about the importance of a safe space for everyone we're working with. Now, what can we do about this as someone trying to learn DevOps or software engineering, right? How can we actually take some of these things that I've been talking about and use these ideas to learn better? Well, the first thing I would say is start with the basics, right? You have to start small. You have to start with the tricycle and then iterate. Or to use the language metaphor, right? Start with saying hello, how are you? Simple conversations. Complete conversations, mind you, right? So it's not single words. We're learning complete conversations, even if they're simple and short. So there are things like this in DevOps that we can do. Like in Kubernetes, instead of building an entire application from scratch, your first step can be to deploy an existing off-the-shelf application that ideally is a monolith and only has one component, and you can learn about deployments, or maybe you could then learn about stateful sets. And from there, you can layer on and go deeper and deeper into all of the other things that are available in a Kubernetes or Dockerized ecosystem. Okay, so this one is important, but it also kind of flies in the face of something I said earlier, which was providing a safe environment, right? We need practical experiences. This might mean that we're actually working on production code or in production environments, but I think that in order to combine this need to have real practical experiences and real goals that can help motivate us, right? And also the need for safety and the knowledge that if we screw up, it's going to be okay and it's not going to cost our company millions of dollars or enough money that it would put our company out of business, whatever size our company is, right? So in order to escape that fear, but also maintain the motivation, this is where I really like home labs or like non-prod environments, right? If you're a developer advocate, maybe it's building your own stack for doing your analytics, right? That gives you a chance to play with the tools. It gives you some of the pain of the fact that it's kind of a production thing, but nobody besides you is depending on it. Nobody besides you is going to yell at you if it's broken, which gives you a degree of safety, right? It's really, really important to seek feedback and to be open to feedback when it is offered to us, right? We all need to be kind to each other. We need to put our feedback in kind words, but we do need to provide feedback and tell each other when we are technically wrong or when we disagree or when someone who's been doing it for a lot longer than us just knows better, right? So we can train our internal monitors to be better the more feedback that we gather from those around us. And we cannot be afraid to admit when we don't know something and to ask. And then the most important thing as a learner, because we talked about the importance of motivation, right, is to just stay positive. You've got this. You will eventually figure it out. Or if you don't, that's okay. Other people have also not figured it out, and they're okay too. Okay, so let's say we're the people who are actually building tools, building platforms, right? Then how can we take some of these lessons and build better tools that maybe provide a gentler ramp for the people who are going to use them and maybe haven't learned the systems nearly as deeply as we have? Well, the first thing I would say that we need to do in this case is embrace the early adopters, right? The early adopters are essentially your learners who have innate motivation. For whatever reason, they really want to learn this stuff, maybe just out of pure curiosity, but they have a motivation that doesn't waver and they will get through the pain. And then you can talk to them and learn from their pains and help the people who don't have that innate motivation not have those hurdles, right? You can smooth those hurdles out for the people following the early adopters. So early adopters, when you're trying to build something new, they're your best friends for feedback. We need to design for accessibility. Pretty much at any step in the onboarding of your tool or platform or product, the question, what should I do next, should be painfully obvious. Or sorry, the answer to that question, of course, right? And so if we have just a hung terminal, that doesn't tell me what I need to do next, unless I have some implicit knowledge of how to stop a process. But it would be great if, when a beginner is learning, that feedback of the next step or the next possible steps, right, is more immediate. And in order to do that, we kind of have to, as I alluded to, meet users where they are. We have to let them know when they've made a mistake, but not hinder their progress if that mistake can be, routed around or the rest of the system can still work, then we should just make it work. We shouldn't make our systems pedantic when they're targeted at beginners, right? Now, this is actually very challenging because A tool that is flexible enough to accommodate the mistakes of a beginner is actually going to be too flexible for the needs of an expert. And this is why I think software engineers start to gravitate towards things like statically typed languages and stricter tests as they progress in their career. But as people who have progressed to like those static things that can strictly tell us when we've made a mistake right away, we need to remember that not everybody knows as much as us, and they might not need those same immediate, tight, strict feedback loops. So what we really need to do is give them a golden path with gentle guardrails. And I think Hazel Weekly put this very well. She said, platform engineering reduces the depth of the stack for developers. That's really, I think, the sweet spot, right? Now, for closing thoughts, I just want to say, I think we kind of had this figured out before, and maybe we just built a bunch of stuff, and we might need to just think about how we did this in the past, and if there are some things that we can learn from that. So this was my first developer platform. I'm guessing some of you could say the same, or that you were using other tools of that era that had these kind of permissive but fast feedback loops as you're building things out. It's a pretty great tool for just learning HTML and CSS as a teenager, or at this point, not even CSS, right? Just HTML with actual presentation markup in it, for those of you old enough to remember that. And this platform had CI/CD, right? CyberDuck was my CI/CD. It was awesome. I got my code right to where I needed. Or if I wanted to test in prod, I could just edit the files right in prod. There wasn't anything more complicated than that. And I even had observability. I had hit counters. So I guess what I'm trying to say is, let's make this fun again. I'm not trying to say that we have to build GeoCities, but what I am saying is that I don't see any reason we couldn't make software development so easy that any 12-year-old on the planet could teach themselves. So that's all I've got for you today. Thank you very much for coming to my talk. I hope you enjoyed it.